Here I'll work through questions 16 through 20. On this question, we want to graph the equation negative 1x minus 3y equals 6. So this is a linear equation. We have multiple ways of graphing this linear equation. I'll show you two. We can graph using the intercepts. So I'll find the x-intercept by letting y equal 0. So substitute a 0 in for y, and you have negative 1x minus 3 times 0 equals 6. Simplifying, you have negative x equals 6. I'll divide by negative 1 to get x equals negative 6. So we have an x-intercept at negative 6, 0. Then we want to find our y-intercept. To find a y-intercept, you let x equal 0. We're going to substitute a 0 in for x, and that gives negative 1 times 0 minus 3y equals 6. Simplifying, this gives negative 3y equals 6. We're going to divide by negative 3 to get y equals negative 2. We have a y-intercept at 0, negative 2. So to graph using the intercepts, we're going to plot those two intercepts, 0, negative 2, and negative 6, 0, which is off our grid here. And we connect those 2 points with a straight line. So as an alternative, we can graph using slope-intercept form. With slope-intercept form, we want to rewrite our equation in the format y equals mx plus b. So our equation is negative 1x minus 3y equals 6. This is called standard form. Slope-intercept form will have the y isolated on one side. So I'll add x to both sides. This gives negative 3y equals x plus 6. And I'll divide both sides by negative 3. And we have y equals negative 1/3 x minus 2. Now that the equation is written in slope-intercept form, I can see the slope is negative 1/3, and the y-intercept is negative 2. So to graph using this slope-intercept form, you're going to start by plotting that y-intercept at negative 2, and then you're going to use the slope to get to another point. The slope is rise over run. So from that y-intercept, we're going to rise negative 1, so we're going to go down 1, and then we'll go to the right 3, that's running 3, and that gets you to a second point on the line. And you'll connect those 2 points, and you can see here we've drawn the same line that we did with the other method. So those are two different ways that you can graph the line. A company discovers that to produce 610 new electronic parts, it will cost $50,190. To produce 950 new electronic parts, it will cost $77,050. Compute the slope of the costs and choose the most accurate statement from the following. We'll read over those statements after we've calculated the slope. The formula for calculating slope is y2 minus y1 over x2 minus x1. In this example, we're given 2 x values and 2 y values. So we'll let this be x1, y1, and this one be x2, y2. So substituting that into our slope formula would give us $77,050 minus $50,190 over 950 parts minus 610 parts. So $77,050 minus $50,190 is $26,860 over 950 minus 610, that's 340. 26,860 divided by 340 is 79. So we've calculated the slope to be $79. $79 per item. The units for the numerator are dollars, and the denominator is number of items. So our slope is representing a cost per item. So let's read this. Each statement is costs are increasing. Costs are increasing at a rate of $76 per item. So this one has the wrong slope. Costs are decreasing at a rate of $79 per item. So our slope is positive, so it's increasing. It's an increasing rate. So we do have the right slope, but it's decreasing. Our slope is increasing. The costs are increasing at a rate of $79 per item. So this one is correct. And these other ones have the wrong slope. So we have the costs are increasing at a rate of $79 per item. Put in slope-intercept form, then give the slope in the y-intercept. We have the equation 10x plus 5y equals 16. This is a linear equation in our standard form. We want to rewrite it into our slope-intercept form. Slope-intercept form is y equals mx plus b. So our goal is to solve for y, to put it into that slope-intercept form. So we're going to subtract 10x on both sides. That gives 5y equals negative 10x plus 16. We'll divide by 5, and that gives y equals negative 2x plus 16 over 5. In our slope-intercept form, the m stands for the slope, and the b stands for the y-intercept. So we can see that the coefficient of our x is our slope. So for this example, m is negative 2. That's our slope. And the y-intercept is this constant here. We have b being 16 over 5, and that's our y-intercept. In this example, we've been given the graph of a linear equation, and we want to find the slope of the line. Now, there are a few different ways that we can calculate the slope of a line. There's a formula for calculating slope, y2 minus y1 over x2 minus x1. So if we can identify 2 points on this graph, we can use this formula. So what I'm looking for to identify 2 ordered pairs is a place where my grid intersects. So I can very clearly see an x value and a y value. So you can see here is where my line is intersecting this grid. And so I know this point is exactly 210. And I want a second point like that. We could use this point right here. You can see this point is exactly intersecting this grid. And we have the point 0, 2. So I'll let 210 be my x1, y1, and 0, 2 being x2, y2. We'll substitute that into the formula. And that would give 2 minus 10 over 0 minus 2. 2 minus 10 is negative 8. 0 minus 2 is negative 2. And we reduce this negative 8 divided by negative 2 is a positive 4. So this equation has a slope of 4. Now we can use these same 2 points to calculate the slope in a different way. The slope is rise over run, and that's the vertical change. Rise is the vertical change, over run the horizontal change. So what I'm looking for is how much do I go up from this point to this point, and these tick marks are going by 2, so this is 2, 4, 6, 8. I'm going a rise of 8, and how much am I going horizontally from this point to this point? And these tick marks go by 2, so that's 2. 2 horizontally. 8 over 2 is 4. If my point was going, if I was looking at the point from here to here, I would say how much is it going down? It's going down 8. That's a rise of negative 8. So going down means I'm putting a negative on the number. And if I go to the left, I put a negative on the number. So negative 8 divided by negative 2 is 4. So we get a slope of 4 with either way of calculating it. On this question, we want to find the domain of the function in the graph. So we're given the graph of a function, and we want to find the domain. The domain is the set of all first coordinates. And the first coordinates are the ones that we use on our horizontal scale. So for this example, the variable used is k. So our domain is going to be all of the k values that are covered in this picture. You can see that we have a lowest point and a highest point. And when I say low, I'm talking about on this horizontal scale. And the lowest point on that horizontal scale I can see is 0. And the highest point on that scale is a 7. And because these 2 points are connected with a line, all of the points in between are included as well. So there are several ways that we can write this, one of them being an interval notation. With interval notation, we're going to write our lower bound, comma, our upper bound. And in this example, because we have these filled in circles, we use brackets on the end. The brackets tell us that the endpoints are included in the set. So this is interval notation. So the meaning of this interval notation can be drawn on a number line. Our domain covers all of the numbers from 0 to 7. So 0 to 7 shaded in between. Notice I'm using filled in circles on the endpoints to include the endpoints. Another way to write the domain would be using inequalities. So we're going to use k as our variable, which is listed here. And our domain is all numbers in between 0 and k, 0 and 7. And notice I've used an equal to so that the endpoints are included. So to include endpoints in interval notation, we use brackets. On the number line, we fill in the circle. And with inequalities, we write the equal to. So our domain is 0 is less than or equal to k is less than or equal to 7.
Thank you for checking out my videos. Have a great day.